Okay, the topic for today's lesson is transformations. But I want to look at transformations of functions. I want to look at what happens when you alter a function, oh, just a wee little bit. So it is helpful to have an actual function in mind. And so the function that I'm going to have in mind is the function y equals x squared. And I'm going to ask myself, what happens to the graph of that function if we replace x with x minus 3? And we notice, ooh, the graph appears to have moved to the right 1, 2, 3 units. And so I ask myself, would that work the other way? And the answer is yes. The function moves to the left 1, 2, 3, 4, 5 units to the left. And so it appears, based on this data, that if we replace x with x minus h, what we get is a translation of the graph of y equals f of x by h units to the right. So replacing x by x minus 4 moves the graph to the right 4. This almost makes sense. Not because we're affecting the, well, if you think about it, you're saying, wait a second, it's x minus 4, we're moving to the right 4, why is that? Well, we're not moving the function, we're moving the axes. When we replace x with x minus 4, we are moving the axes 4 to the left, which makes the function appear to move to the right. That's what's really going on. Of course, the easier translation to do is to say, I want to know what x squared plus 3 looks like, or what x squared minus 5 looks like. And sure enough, x squared plus 3 is a shift of x squared 3 up, and x squared minus 5 is a translation of the blue graph 5 units down. And so if I have y equals f of x plus k, that's a translation of y equals f of x by k units up. Now you're saying, wait a second, why is this one counterintuitive, but this one intuitive? Well, really, you're starting in both cases with y equals f of x. In this case, you take that x and replace it with x minus h. It moves the axes left, which appears to move the graph to the right. But in this case, you're replacing y with y minus k. And then this k gets moved over to the right side. So you're really moving the axes down, which appears to move the function up. It just happens that this one looks intuitive because it's got the plus k at the end, and you're thinking, well, obviously that moves everything k units up. Well, let's look at what happens if we multiply an equation, one side of an equation, by a. If we multiply the equation by a, nothing happens. But what happens if we multiply one side of the equation by a? Let's see, let's get rid of this. Oh, that's not good. Let's get rid of this. And let's look at 2x squared. Or 0.3 3x squared. The 2x squared is narrower. The 0.3x squared is wider. What really happened? Well, when we multiply the function by a, what we get is a one-way dilation, also called a vertical stretch. We stretch out the y values by a factor of a. That is to say, if we have some graph and then we multiply that expression by 2, then for any x value, if I find the corresponding x value, if I take that x value and I follow it up to the red graph, this y value is twice as big as that one. That's the way it goes. The 2f graph, all the y values are twice as big as their corresponding values on the f graph. Which means, if we were to play this game, this is a one-way dilation. In this case, it's a horizontal stretch by a factor of b. And the same reasoning applies. So if I were to come over here and I were to replace the x in x squared with x over 2, I get a graph that has, the blue graph has been stretched out horizontally. Whereas, if I were to replace the x in x squared with some decimal number, like 0.4, oh, that's not going to work here. Get rid of that. Okay. If I were to replace the x in x squared with x divided by some decimal number, then the graph gets shrunk in the horizontal direction by that factor. It gets shrunk. Okay? Okay. So there are some things that you should know how to do between now and the time we gather. You should know h of x is x cubed. That looks roughly like this. If it helps you, that's 1, 1, that's 0, 0, that's negative 1, negative 1, if that helps you. You should be able to come up with graphs of y equals x cubed plus 2, y equals x minus 3 cubed, and y equals x minus 3 cubed plus 2. You should know how to come up with all three of those graphs without much trouble. Also, right, if you hit the pause button, because you got to write those down. Okay, if you didn't hit the pause button, you got to go back. G of x is 2 to the x. 2 to the x looks like this. Goes through 0, 1, goes through 1, 2. That is g of x. You should be able to come up with graphs of 2 to the x minus 3 and 2 to the x plus 1. You should also know, here's a generic graph. Just a generic graph. Looks sort of like a bell curve, but not really. This point is at 0, 3/2. This point is at 1, 1. This point is at negative 1, 1. We appear to be asymptotic to the x-axis. You should be able to generate a graph of f of x minus 2 plus 3/2. And you should be able to generate that just by thinking to yourself, what does this have to look like? What does f of x minus 2 mean for the function? What does the plus 3/2 mean for the function? You should be able to come up with the image graph for that function after that transformation. Okay? Okay. There's everything that you should know about transformations before you show up to class.